The path of love is never smooth, but mine's continuous for you. You're the upper bound in the chains of my heart. You're my axiom of choice, you know it's true. But lately our relation's not so well defined, and I just can't function without you. I'll prove my proposition, and I'm sure you'll find we're a finite, simple group of order two. So if you watched my last video, you understood all of the first verse and none of the second verse. We'll first discuss the first two lines of the second verse. But lately our relation's not so well defined, and I just can't function without you. So the technical math terms to discuss here are relation, well-defined, and function. We'll start with the word function. Here's a quick shout out to my favorite high school math teacher, Dr. Bruce White. He used to say a function is an usher. I actually don't 100% agree with this. I think a one-to-one function is an usher, and one-to-one is actually a term mentioned later in this song. So an usher takes a person and puts them in a seat in a theater. A person can't occupy multiple seats, and a seat can't contain multiple people. This is exactly what a one-to-one function does, except often, but not always, both the people and the seats are numbers. So a one-to-one function in math class usually takes some group of numbers and assigns them to some other group of numbers over here, and one number over here can only correspond to exactly one number over here, and vice versa. It's like if I put nails on a pegboard. So let me put, let's say, 4 nails on the left, and maybe I'll put 5 nails on the right. And then I'm going to put rubber bands around the nails. So I'll put a rubber band around one of these nails and one of these nails. And in order to be a one-to-one function, I need to have at least as many nails over here as over here. So here I have more, which is good. I have a little bit of room for leeway. So I'm going to put a rubber band around one nail over there and one nail over there. It might be a little bit tighter in real life. And to be a one-to-one function, no nail on either side can have more than one rubber band around it. So maybe I can do this. And now all of the nails on the left at least are paired. The nails on the right don't have to be paired. And then in math class, you probably assign numbers. So let's say 8, 2, -1, 17. And we might put like 0, -2, 4, 5, and 7. And then in math class, they would write, maybe you didn't like this notation, but instead of 2 rubber bands, 2 nails paired up with a rubber band, they would write something like this, f of 8 equals -2. But that means the exact same thing as this. And then they would write, what are these paired? F of -1 equals 0. So all that silly notation is really just a diagram of rubber bands. That's a one-to-one function. Now to be a function, every one-to-one function is a function. So this is already a function. But we allow a little bit more stuff. So in a function, I'm just going to change this. I'm going to allow multiple rubber bands to be around the nails over here. So if I change that to this, that's still a function. So both 2 and 17 go to 5. That's okay. I still am not allowed to have multiple rubber bands around the nails over here. 8 cannot go to -2 and 0. But multiple things can go to a number over here. I could have all of these go to 5. It would be okay. So this is why I think the usher analogy fails for a function in general that may not be a one-to-one function, because this allows multiple people to sit in the same seat. Now I suppose if the people were particularly small and particularly liked each other, this would be physically possible. You could fit 2 people in one seat. However, the theater probably would not allow this. Certainly the ticket taker would not allow multiple people to enter on one ticket, and they would get a funny look if they said they were planning on sitting in the same. So continuing with the usher analogy, even though it's no longer a great analogy, a relation is a true free-for-all. It not only allows multiple people to be in the same seat, it allows one person to be in multiple seats. And maybe this part is actually a little bit more believable if you wanted to put your bag in the seat next to you, you're particularly antisocial, you just don't want people sitting next to you, you want to be sprawled out, or you're particularly large. These are all reasons why you might buy multiple seats. Where it becomes less believable is like Bob could be in seats 1, 2, and 3, and Stacy could be in seats 1 and 4, and Alice could be in seat 1. This doesn't actually work in a theater. So, a better analogy for a relation is maybe food eaten at a potluck. So, let's say Bob, Alice, Stacy, and Joe go to a potluck, and the food available there is sandwiches, cake, chips, salad, and pork chops. And we don't care who brought what, we just care who ate what. So let's say Bob ate sandwiches and cake, and Alice only ate the cake, and maybe Stacy ate everything, and Joe is on a diet and only ate the salad. So now one person can be eating multiple foods, and a food can be eaten by multiple people, and now we get a better real life representation for the free-for-all of a relation. And of course, in math, often the people are numbers and the food are numbers, but not always. A well-defined function or relation is basically one where everything's clear. So in the usher example, that would be if people's tickets had printed seat numbers. That makes the usher's job easy. They take a person, the ticket tells them where to put them, there are no issues. If there were just general tickets with no printed seat numbers, then they might start to run into problems if they tried to seat a big group, for example, and then they might have to start moving people around. So we like it when things are well defined. Airline ticket counter employees would love it if their job was well defined. They wouldn't have so many angry customers. In the potluck example, not well defined might be like if all the food was covered and you had to commit to eating the food before seeing what it was. That would not be as fun of a potluck as if you got to choose your food after seeing it. So people like well-defined situations, and mathematicians like it too. Love, however, is often confusing, the very opposite of well-defined, and the Klein group knew this. But lately our relation's not so well defined, and I just can't function without you. Wow, that was a lot of work for 2 lines, so I'm actually going to stop this video here and continue with the next 2 lines of this verse in the next installment.